Hello everyone, welcome to Akshara IT Foundation. This is Srinivas from the faculty. Let us go to the today's class. So in our previous class we have discussed about the heights and distances, right? So from that synopsis we have completed entire trigonometric topic, but in between we have left two synopses 5 and 6. They are including the graphs, and that too they are not up to your standard. Okay. So again we are having the same trigonometry topic in 10th class. We will include both the topics in the 10th class. Okay. So until then we are discussing about the heights and distances also, and that too we are not including these two synopses in your revision test. Okay, so prepared well for the remaining synopsis. Then we are going to discuss the new topic today. So that is properties of triangles. Okay, properties of triangles, which is included by the trigonometric concept. This chapter is included by the trigonometric concept. Okay, so before that let us discuss about the circumcircle. For example, if you take a triangle like this, and for this triangle I am just drawing or just constructing the perpendicular bisectors. Perpendicular bisectors. Bisecting means dividing into two equal parts, and perpendicular means which has to make the angle 90 degrees. So perpendicular bisector means I am drawing a line which is divides the one of the side of a triangle into two equal parts at 90 degrees angle. So this line is called perpendicular bisector. Okay, na? For this one of the side of a triangle I have drawn one perpendicular bisector. Okay, which side I have drawn? BC side. Now I am drawing one more perpendicular bisector to another side AC, and we can draw one more side AB also. So I have drawn three perpendicular bisectors to the three different sides of a triangle. And while you are observing, these three perpendicular bisectors are intersecting at a point. This is called circumcenter. This is called circumcenter. From this point, the distance between this point to any vertex of a triangle are equal. This circumcenter is represented with the letter S. The circumcenter is represented with the letter S. So from this diagram we can say that the distance between S and A is equals to S and B equals to S and C. Okay, na? And while you are constructing from this, if you take any radius like SA, SB, SC, any distance you can take in a circular, and if you draw, it will form a circle. So from this we can say that a triangle whose three vertices are lying on a circle is called circumcircle. Okay, na? And the perpendicular bisectors intersecting point or concurrent point is called circumcenter. We are representing with S. Okay, na? And SA, SB, SC are circumradius. SA, SB, SC. These are called circumradius. And this one we are representing with capital R. Okay, na? In case if you take a quadrilateral is having four vertices on a circle. Having four vertices on a circle, that type of figure is called cyclic quadrilateral. That is called cyclic quadrilateral. Here triangle is there, no? This is called circumcircle. Okay, and how the center is formed? We are taking the perpendicular bisectors to the each side of a circle, and the perpendicular bisectors are making a concurrent point. Concurrent point means more than two lines intersect or meet at a point is called concurrent point. Okay, na? So this is called circumcenter. Circumcenter is represented with the letter S, and the distance between center to the any corner is circumradius. Okay, na? And the circumradius is represented with the letter R. Now we are going to discuss about the sine rule and cosine rule and projection rule. You have to remember the sine rule and cosine rule. First, the sine rule. The sine rule is a by sine A equals to b by sine B, that equals to c by sine C, equals to 2r. This is the sine rule. And what are ABC? ABC are the lengths of a sides of a triangle. For example, if you take a triangle like this, it can be any triangle. It can be acute angle triangle, right angle triangle, and obtuse angle triangle. Each triangle having 3 sides, right? So now I am taking the triangle ABC, capital A, capital B, capital C. The side which is opposite to vertex A, the side which is opposite to vertex A is taken as small a. So the small a is a length of a side which is opposite to vertex A. Same way, the small b is a side which is opposite to vertex B, and small c is a length of a triangle, a length of a side which is opposite to vertex C. Okay, na? So from this we are applying the sine rule, that is a by sine A equals to b by sine B equals to c by sine C equals to 2r. Okay, just let us see this proof. I am just taking by acute angle triangle. Okay, na? Okay. So we can have the proofs for different type of angles like acute angle, right angle, and obtuse angle, that we can prove any one of them. So remaining we can write similarly. Okay, na? So I am taking the side BC here, and according to the circle it will be a chord. Am I right? Yeah, it is a chord, and it is making an angle on the remaining arc. Let us consider as A. So this is triangle ABC, nothing but circumcircle. Okay, and that angle A is acute angle. Angle A is acute angle. Now I am constructing one more angle BDC. I am constructing one more angle BDC. Okay. And here you should remember the point, that is the chord BC in a circle. Chord is nothing but the line segment having both endpoints on the circle. The line segments having both endpoints on the circle is called chord, and the chord of a circle is making equal angles on the remaining arc. That means if you take this chord BC, it is making the equal angles on the remaining arc. That means angle A equals to angle A. So that means we can also take this one as angle A. And let us construct this one. BD is passing through the center. Let us think BD is passing through the center, or we have to construct a BD line segment which has to passes through the center of a circle. And here to here, the center to the corner is radius, nothing but circumradius. We are representing with the letter capital R. So this is also here to here also capital R. So R plus a total distance is 2R. So from this we can recognize that, from this we can say that BD is the diameter of the circumcenter 2R. BD equals to 2R. Okay, na? And we know that BDC is a triangle which is lies on the semicircle. BD is a diameter, means the diameter divides the circle into two equal parts. Equal parts means each of the part will be semicircle. Okay, na? And we know that the angle in semicircle is 90 degrees. Angle in semicircle is 90 degrees. This one. Okay. Now I am taking this triangle sine D. I am applying the sine ratio. Sine D equals to opposite side by hypotenuse. So for this D, opposite side is BC, and the hypotenuse is BD. The hypotenuse is BD. And we know that angle A and angle D both are equal, right? Because these two angles are made by the, are subtended by the same chord. Okay. So in the place of D, I can write A. So in the place of D, I can write A. Sin A equals to, BC is nothing but this is the side which is exactly opposite to the vertex A. So we can consider this one is small a. Okay. So in the place of BC, I can write small a. BD length is nothing but 2r. Now just I am going to interchange. So A by 2r equals to sin A. Sin A and 2r I am going to interchange. So from this we have to decide that A by sin A equals to 2r. So similarly at angle B also we can prove same like that. B by sin B equals to 2r. C by sin C equals to 2r. Okay, now this is the sine rule. A by sin A equals to B by sin B equals to C by sin C equals to 2r. Okay. Important formula. Let us go to the second rule, cosine rule. Okay, so the cosine rule is, B square equals to A square plus C square minus AC cos B. B square is equal to A square plus C square minus AC cos C. Sorry, 2AC cos C, 2 also there. Okay, na? Or if you start from A square equals to B square plus C square minus 2BC cos A, or C square is equals to A square plus B square minus 2AB cos C. So this is called sine rule. Any one of them we can use. Okay, na? B square equal to A square plus C square minus 2AC by cos B. Okay. Now, or else we can write this one as, we can represent this one as cos B equals to A square plus C square minus B square by 2AC. Or we can write the same thing as cos B equals to A square plus C square minus B square by 2AC. Okay, no? Right. So, let us see this one. Still we don't need that. We don't need we have to remember the formula for this. Okay. So let us see this. Now I am taking a acute angle triangle like ABC, and B is having an acute angle. B is having an acute angle. Now I am just constructing a perpendicular line AD, the line which is perpendicular to BC. So AD is perpendicular to BC. Okay, now from this is angle B. I have taken as acute angle. Angle B we can take it as right angle. Angle B we can take it as obtuse angle. So three conditions, no, any one of them you can know. Okay, na? Right. So from this, I am using this right angle triangle. The right angle triangle ADC I am taking. In triangle ADC. That means this triangle. Right side triangle. This triangle. I am using the Pythagoras theorem. For this right angle, opposite side is AC. So hypotenuse square AC square is equals to AD square plus DC square. AD square plus DC square. This is one of the equation. And the second one, AB square. Second equation, AB square equals to, this is the hypotenuse, right? And AD square minus BD square. AD square minus, AD square plus BD square. Clear? I am just using the Pythagoras theorem from the triangle ADC and the triangle ADB. Two triangles. From the first triangle, I have written that AC square is equals to AD square plus DC square. From the second one, I have written that AB square is equal to AD square plus BD square. Okay. Now from this, from the first condition, I can write AD square equals to, from this one, AD square equals to plus DC square, bring this side, it will be minus DC square. So we can write AC square minus DC square. That should be substitute in the second equation. That means AB square equals to, in the place of AD square, I can write AC square minus DC square plus BD. BD is nothing but the distance from B to D. I can write the BD using BC formula. How can I write BC minus DC? Okay, na? BC minus DC. Total distance minus DC will be remaining BD. So in the place of BD, we can write BC minus DC. That is nothing but looking like A minus B whole square formula. What is A minus B whole square formula? A square plus B square minus 2AB. So from that, BC square plus DC square minus 2BC into DC. Okay, na? So AB square. Okay. Yeah, from this we can say that AB square, AB is nothing but length of C square is equals to AC square value is nothing but B square minus D square plus DC square. Minus DC square plus DC square cancel plus BC distance means small a, because BC is the side which is exactly opposite to the vertex A. Okay, na? And minus 2BC into DC. So before that, let us take that BC into DC. From this angle B, I am just writing cos B. From this triangle, I am using that cos B concept. Cos B is nothing but adjacent side by hypotenuse. What is adjacent side? BD. Hypotenuse is AB. Okay, na? So from this we can write BD equals to AB into cos B, because AB is dividing this side. When you transpose, it is multiplying. So in the place of BD, we can write AB cos B. Yeah, BD we have to find. Okay, let us take that. Here we are getting angle C now. I am using that angle C here. By using that angle C, we will write. Okay, let us write from the angle C. This one. From this angle C, cos C equals to, what is cos C? Cos C equals to adjacent side CD, hypotenuse is AC. So from this CD and DC both are same. In the place of DC, we can write AC cos C. Okay, na? So that is equals to BC. BC is nothing but opposite side, we can write A. And in the place of DC, we can write AC cos C. AC cos C. So write that C square equals to B square plus A square minus 2AB. AC is nothing but the side which is exactly opposite to the vertex B. The length of AC is small b and cos C. So this is the cosine rule. C square is equals to, this one, C square is equals to A square plus B square minus 2AB cos C. Because I have taken the angle at C, acute angle at C. If I take acute angle at B, I will get B square is equal to A square plus B square minus 2AB cos B. Okay, na? These are the two formulas you should remember. And one more formula, that is projection rule. Yeah, the projection rule is third one is projection rule, that is A cos B. Yeah, A into, or let us take that the small a is a side of a triangle which is opposite to the vertex A. So A is equals to B cos C plus C cos A. This is the projection rule. Or small b equals to C cos A plus A cos B. A cos B. Okay, na? A, B, C all. If you take A, it starts from repeating A, B, C, B, C, A and C, A, B. Like this concept. If you take starts from A is equal to B cos C plus C cos A. Starts from B is equals to C cos A plus A cos B, and C is equals to A cos B plus B cos A. Okay, na? So this is the projection rule. Okay. Now let us start that exercise problems or concept based questions by using these three rules: sine rule, cosine rule, and projection rule. Okay. So let us see the first problem. Concept based questions. Yeah, the first question, the values are given that if B is equals to 10 centimeters, B is equals to 10 centimeters, and the R is equals to 5 centimeters, then we need to find the value of B. We need to find the value of B. I am using the sine rule because I can identify the R value in sine. What is sine rule? A by sine A equals to B by sine B equals to C by sine A, sine C equals to 2R. This is the cosine rule. Now I am taking that, what we have to find actually, capital B we have to find. Okay, now I am taking B value, that means B by sine B is equals to 2R. B by sine B equals to 2R. Or we can take A by sine A is equal to 2R, B by sine B equal to 2R, C by sine C equals to 2R. Because I need that B value is given now. So that's why I am using the middle one. So in the place of B, I can write 10 sine B is equals to 2 into R. R value how much? R value is 5 centimeters. R value is 5 centimeters. So 2 5s are 10. Now sine B equals to 10 by 10. 10 by 10 value is 1. So according to the trigonometric value table, the sine value is 1 at sine 90 degrees. Sine 90 degrees. So both sides sine cancel. Therefore, B value is 90 degrees. B value is 90 degrees. Okay, na? So by using the sine rule, I have find it like this. Okay. Now let us go to the next problem. The second one is given that if tan C minus A by 2 equals to K into cot B by 2, then we need to find out the value of K. Now let us consider C minus A by C plus A values. According to the triangle, if you take the triangle ABC, this is properties of triangle, no, we should use triangle here. ABC small c is exactly located to the vertex CAB. Okay? So small c is equals to, by using the sine rule, how can you write? C by sine C equals to A by sine A equals to B by sine B equal to 2R. 2R can be any constant number. Here what is the R value given here? 5. 2R value how much? 10 we got. So it can be 10, 20, 30, 0.5, 0.3, anything. 2R value can be any value. Now that value I have taken as K. That means A by sine A equals to B by sine B equals to C by sine C is equals to K. So from this we can write C is equals to K into sine C. Am I right? So sine C is dividing now. When you transfer it is going to multiply. Yeah. Sine C value K sine C. Here also we can write in the place of C. In the place of C we can write K into sine C minus same way K into sine A divided by K into sine C plus K into sine A. So you can take K as a common term from the numerator as well as denominator. So numerator K, denominator K can be cancelled. Therefore the remaining value sine C plus sine A, sine C minus, sine C minus sine A by sine C plus sine A. In the previous topic we have discussed about the transformations formulas. Sine plus sine, sine minus sine. cos plus cos, cos minus cos. 4 formulas we have discussed, right? So by using the formulas, sin minus sin formula, 2 cos sin. 2 cos sin. First addition, c plus a by 2. Second subtraction, c minus a by 2. 2 cos sin. Sin minus sin. But sin plus sin is 2 sin cos. 2 sin cos. So first addition, c plus a by 2. Subtraction, c minus a by 2. Okay, na? Sin plus sin, sin minus sin. Yeah, both sides 2 cancel. Yeah, both sides 2 cancel. Now I am taking that cos c plus a by 2, sin c plus a by 2, we are not going to cancel here because of both are different ratio. Cos by sin can be cot. Here also sin by cos can be tan. Okay. But here tan value is there. See, tan c by a by 2. See this one. While you are observing last two terms here, these two, sin by cos becomes tan. So we can write tan c minus a by 2. Okay. Right. Now this one, what about this one? Cos by sin value? Cos by sin value is cot. Cot c plus a by 2. But we did not get cot c plus a, but this is b by 2 value we got. Let us see. This one tan c minus a by 2. Okay, until then correct? Yeah. Now let us see this. Now cot c plus a, I am going to write c plus a by 2, I am going to write 180 minus b by 2. Because in the triangle a plus b plus c is equals to 100 degrees, right? ABC is a triangle, a plus b plus c is equal to 100 degrees. So a plus b is equals to 180 minus c. So I have c plus a or a plus c. A plus is equal to 180 minus b. That is equals to cot 180 by 2, 90 minus b by 2. 90 minus b by 2. 90 minus b by 2 what? 90 minus b by 2 value is first quadrant. First quadrant, all positives, all ratios are positive. Whenever 90 degrees, cot becomes tan, because cot 90 minus theta becomes tan theta, complementary angles. So this will be tan b by 2. Tan b by 2 into tan c minus a by 2. But this value is coming from c minus a by c plus a, right? Okay. Now tan I can write 1 by cot. Tan b by 2 I can write 1 by cot b by 2 into tan c minus a by 2. 1 by cot b by 2, transpose this side, it will be cot b by 2 into c minus a by c plus a, that is equals to tan c minus a by 2. Just this one compare with given condition. This one compare with given condition. What is the condition? Tan c minus a by 2 is equal to k into cot b by 2. So tan c minus a by 2 is equals to k into cot b by 2. So what is the k value? C minus a by c plus c. Okay, na? Please note that. Let us go to the next problem. Yeah, problem number 3. Now sin square a plus sin square b is equals to sin square c. Sin square a plus sin square b equals to sin square c. We need to find the value of angle c. We need to find the value of angle c. Now here also I am going to apply the sine ratio, means sine rule. What is the sine rule? A by sin a equals to b by sin b equals to c by sin c, equal to 2r, or let's just take it as a constant term k. Okay, na? Now in the place of sin a, I can write from these two. I am just comparing, like a by sin a value is equals to k. Just transpose this side. A by k is equals to sin a. Okay, na? So in the place of sin a, what I can write? A by k. A by k. Sin square means a by k whole square. Similarly, we can write the sin b value is b by k. is equals to c by k whole square. Now just expand this, a square by k square plus b square by k square is equals to c square by k square. It is nothing but a square plus b square by k square is equals to c square by k square. Both sides cancelled. So a square plus b square is equals to c square. It is looking like Pythagoras theorem. Am I right? It is looking like Pythagoras theorem. C square is equals to a square plus b square. Hypotenuse square is equals to side square plus side square. That means there is a angle here 90 degrees which is opposite to C. The C is exactly opposite to the vertex C, right? A is exactly opposite to the vertex A. B is exactly opposite to the vertex B. So from this we can say that angle C is equal to 90 degrees. From this we can say that angle C equals to 90 degrees. Please note that. Then we will go to the next problem. Yeah, question number 4. The question number 4 is given that A value 30 degrees and B value 30 degrees. Sorry, A value 60 degrees and B value is 30 degrees. Then we need to find out the ratio of A is to B is to C. Okay, na? What is the ratio? Small a is to small b is to small c. Okay? Yeah. Now what is C value here? C value according to the Pythagoras theorem or according to the triangle property. Sum of three angles of a triangle is 180 degrees. So angle A is equal to 60 degrees, angle B is equal to 30 degrees. So 60 plus 30, 90 degrees. So what is angle C then? Angle C is 90 degrees. According to the triangle property, angle C is equals to 90 degrees. Okay, na? Now we should take A is to B is to C. What is A value? A is nothing but the side which is opposite to vertex A. This is B and it is the side C. Okay, na? Yeah. So how we find that sine rule here? Can we apply sine rule? Directly we will get the answer. Okay. Let us find that A is nothing but A by sine A. Small a by sine A is equal to small b by sine B equals to small c by sine C is equals to 2r according to the sine ratio. Okay. So from this I am just taking in the place of 2r I can take k. That means A by sine A equals to B by sine B equals to C by sine C, that is equals to k. K can be 2r. Okay. Now according to this, A value is equals to k into sine A. Sine A is nothing but sine 60 degrees. What is sine 60 degrees value? Sine 60 degrees value is root 3 by 2. So this is k into root 3 by 2. So similarly B value, B is equal to k into sine 30 degrees. Okay, sine B is nothing but 30 degrees. Sine 30 degrees value how much? 1 by 2. Similarly C value, sine C. Sine C means sine 90 degrees. K into sine 90 degrees value how much? Sine 90 value 1. So just take these values in the place of A. I can write k into root 3 by 2. That is 2. In the place of B we can write k into 1 by 2. And in the place of C we can write k into 1. So all are having the same term k we can eliminate from every term. Then what is remaining? Root 3 by 2 is to 1 by 2 is to 1. But here 2 is no. First two terms having 2. I am just multiplying 3 terms with 2. 2 into root 3 by 2, 2 into 1 by 2 and 2 into 1. So numerator denominator cancel. That is root 3 is to 1 is to 2. 2 ones are 2. This is the ratio between the sides of a triangle ABC where angle A is equal to 60 degrees, angle B equals to 30 degrees. Okay. Let us go to the next problem. Problem number 5. the fifth question is given same the ratio A is to B is to C. This time ratio is given A is to B is to C. The value is given that 2 is to root 6 is to root 3 plus 1. Okay, so we need to find out the value at angle C. Okay, now I'm just using that sine ratio. So for that sine ratio, the common topic for sine and cos having the same values at 45 degrees. 45 degrees containing the value 1 by root 2, right? Now I'm just multiplying every term with by 2 root 2 to get 1 by root 2 here. Okay. Now here 2 cancel. What is the answer? 1 by root 2. Now here this we can write as root 6 by root 2. Root 6 by root 2 we can write root or 6 by 2. 2 table in 6 3 times cancel. That means root 2 is cancelled in root 6 in root 3 times. So root 3 by 2. That is equal to this value we don't know. So root 3 plus 1 by 2 root 2. Root 3 plus 1 by 2 root 2. Now just I am applying the values of sine ratios. This is 1 by root 2 is the value for sine 45 degrees. And this is the 1 by root 3 by 2 is the value for sine 60 degrees. So in a triangle, we know that sum of three angles equals to 180 degrees, right? Yeah, 45 plus 60. 45 plus 60, how much? 105. So what could be the remaining value? 75 degrees. Remaining value is 75 degrees. Therefore, first one is 45 degrees, A value 45, B value is 60 degrees. Now angle C is equals to 75 degrees. Angle C is equals to 75 degrees. Yeah, please note that. We will go to the next problem. Problem number 6. Okay. So the sixth problem is the side of an equilateral triangle is 8 cm. Equilateral triangle means all sides are equal, all angles are equal. That means each angle 60 degrees. All sides are equal, all angles are equal in equilateral triangle. Now what we have to find? We have to find the circumradius. What is circumradius? Circumradius is nothing but capital R. Capital R will be available according to the formulas we learned today. That is in sine rule. Sine rule is A by sine is equals to B by sine B equals to C by sine is equals to 2R. Now I can take anything, that is A by sine A is equals to 2R. Okay. So A value is nothing but side of capital A, and 8 and the sine 60. A value is 60 degrees, that is equals to 2R. What is sine 60 degrees value? Sine 60 degrees value root 3 by 2. Root 3 by 2. That is equals to 2R. I can cancel both sides 2. Therefore, the radius is equals to 8 by root 3. Okay, na? Therefore, the radius equals to 8 by root 3. Now, let us go to the next problem. Problem number 7. The seventh one is given that if A value, B value, C value, A is equals to 3 centimeters, B is equals to 4 centimeters, C is equals to 5 centimeters. Then the area of a triangle. Area of a triangle, let us identify. While you are observing 3, 4, 5, these are the measurements of Pythagorean triplet. That means square of any two sides is square of the third side. See, 3 square plus 4 square. 3 square value 9, 4 square value 16. So 9 plus 16, 25. 25 will be the square of 5. That means sum of the squares of any two sides is square of the third side. Then it will be the right angle triangle. 3 square plus 4 square is equal to 5 square. 3 square value 9, 4 square value 16, 9 plus 16, 25. 25 is nothing but 5 square. Now from this, we are identifying that 3, 4, 5 are the measurements of right angle triangle. From this right angle triangle, we can consider 4 as base and 3 as height, or 3 as base, 4 as height. So area of triangle formula, what is area of triangle? Regular formula of base into height. So I am considering base value is 4, height value is 3. 2 table in 4 2 times, 2 3s are 6 centimeters square. Therefore the area of triangle is 6 centimeters square because all of the measurements are given in centimeters. If all of them are given in meters, the answer will be the meter square. Let us go to the next problem. Yeah, the problem number 8. Triangle ABC equals to, eighth one, in triangle ABC, we need to find that B minus C by A. Okay, na? B minus C by A value we should find. Okay. Let us see that while you are observing that options are given, that sine and sine, sine by sine, cos by cos, sine by sine, cos by sine, like that. That means for just applying the sine rule, in the sine rule we can write that A by sine A is equals to B by sine B is equals to C by sine C is equal to 2 or nothing but K. So in the place of B we can write K into sine B minus K into sine C by K into sine A. So numerator K common, numerator K, denominator K cancel. What is the remaining value? Sine B minus sine C by sine A. So the numerator is in the form of transformation formula sine minus sine. Sine minus sine is nothing but 2 cos sine. 2 cos sine. So denominator sine A. Sine A I am writing by using the formula or condition for the triangle. Sum of three triangles is, sum of the angles in triangle is 180 degrees. From this angle A we can write 180 minus B plus C. Angle A we can write as 180 minus B plus C. Okay, na? That is equals to 2 cos B plus C by 2 into sine B minus C by 2 divided by 180 minus second quadrant sine ratio positive. Whenever it is 180, sine becomes sine. So it is sine B plus C. So we can write that sine A as sine B plus C. Now I am just applying here the same condition. I am writing 2 cos B plus C by 2 and sine B minus C by 2 divided by sine B plus C. But here numerators both are in the form of B plus C by 2, B minus C by 2. By 2 is there. So that means if you take that sine 2 theta formula, sine 2 theta is nothing but 2 sine theta cos theta. Or sine A formula, 2 sine A by 2 cos A by 2. Same way this one we can write 2 sine B plus C by 2 cos B plus C by 2. When a 2 sine cos formula. Numerator 2, denominator 2 cancel. Cos B plus C by 2, cos B plus C by 2 cancel. What is remaining? The remaining part is sine B minus C by 2 by sine B plus C by 2. Okay, no? That is our required answer. So let us go to the next problem. Yeah, problem number 9. That is given that, yeah, if triangle ABC, if A cos B is equals to B cos A. If A cos B equals to B cos A, what we have to find? We should find the value, yeah, that value only we should find. Okay, na? Now here also I am applying the sine rule in the place of A, in the place of A, in the place of B. In the place of A, how can I write that is A is equals to 2 or sine A, am I right? I am writing the formula A by sine A is equals to 2R or B by sine A equals to 2R. So in the place of A, I can write 2R sine A into cos B. That is equals to B also I can write 2R sine B cos A. Both sides 2 are cancelled. What are the remaining? Sine A cos B equals to sine B cos A. Now this RHS part I am just bringing towards LHS. That is sine A cos B. This plus term becomes sine B cos A. That is equal to 0. Not that anything means will be 0. Right. Now this will be now sin A cos B minus cos A sin B is the formula for sin A minus B. This is the formula for sin A minus B, and in sin table sin 0 degrees we are equals for sin 0 degrees. 0 value will come for sin 0 degrees. So both sides sin cancel. So A minus B is equal to 0, A is equal to B. This is the condition. That is the condition we should learn. Okay, na? But capital A, capital B is given, but in the options are given in small a, small b's. Okay, now how to write that one? Capital A. What is capital A here? According to sign. Angle A, no. Angle A is equal to angle B. We can write that from that. Yeah. So we can apply the sine rule again. From that sine rule, we can say that in the triangle A, if you take that angle A, opposite to vertex, opposite side by hypotenuse. Sine rule what? Opposite side by hypotenuse. Side, opposite side is A only, no? Hypotenuse, let us take it as 2r. A by 2r. This is also B by 2r. Both sides 2r cancel, A is equal to B, that's it. Okay, na? Let us go to the next problem. Yeah, let us say the problem number 10. That is given that A value, B value is given. We need to find the C value. What is A value? A value is 20, B value is 21, and cos C also given. Cos C is equals to 4 by 5. We need to find the C value. Now A, B, two values, two measurement values are given. One of the cos value is given. So we can, it is similarly to the cos rule, cosine rule, right? What is cosine rule? C square is equals to A square plus B square minus 2AB cos C. We need to find C only, no? We need to find C. So I am using C only, cos rule. Or else if you want to find B value, B square is equal to A square plus C square minus 2AC cos B we should use. But here C only we should find. I am just substituting here. C value, C square is equal to A value how much? 20. 20 square plus B value is 21. 21 square minus 2 into A value 20, B value 21. Cos C value directly 4 by 5. Now denominator 5 in 20 4 times. Okay, now 5 4s are 20. Now C square is equal to 200 square. At 20 square becomes 400. 21 square will be 441 minus 2 4s 8. 8 4s are 32. 32 into 21. Now add these two. It will be 841 minus 32 21s. So 1 table 32 times. Here 64 times. So this is 672. Subtract both of them. 841 minus 672 is nothing but 169. Okay. So C square value 169. C square is equal to 169 is a square number. 13 square both sides square cancel. C value is 13. That's it. That is the answer. So until then concept based questions are completed. So let us go to the exercise problems. The first problem. What is the first problem? In triangle ABC, sigma of, sigma into A square, sigma A square into cos square B minus cos square C. Okay. In a triangle ABC, we need to find that sigma A square into cos square B minus cos square C. Okay. Now sigma is nothing but sum of. In a triangle, first we have to take A square, then B square, then C square. Okay, na? So from this one we can expand that one. A square into cos square B cos square C. So simply just remember A, B, C condition. Plus if A completed B square means it will be cos square C minus cos square A. Plus C square into cos square A. sorry, cos square A capital letter, yeah, cos square A minus cos square B. Just multiply all of them. That is equals to A square cos square B minus A square cos square C plus B square cos square C minus B square cos square A plus C square cos square A minus C square cos square B. Okay, na? I am just multiplying each of them. Okay. Now, yeah. So I am going to write cos B terms together. Cos B. Where is cos B? A square cos square B, C square cos square B is there. That means from first term, last term, I can write A square cos square A, sorry, cos square B minus C square cos square B. Okay, I have written together like this plus C now, B completed now, so B square cos square C and this one minus A square cos square C. So first I have written cos square B terms together, cos square C terms together. Now remaining cos square A terms. So C cos square A or C square cos square A minus B square cos square A. Now from the first two terms, from these two, I am just applying is a formula of algebraic identity A square minus B square is equal to A plus B into A minus B condition. So this one I can write A cos B whole square, C cos B whole square. This means A square minus B square formula, A square minus B square formula, A plus B into A minus B, A cos B minus C cos B. Okay, na? Now this one also. So can we apply or having any chance to applying that? Or we are not getting any formula, so we do one thing, just up to here, first two steps are we are leave like that. So what is the remaining? So this one I am just trying to apply projection rule. What is projection rule? Projection rule, small a is equals to B cos C plus C cos B. Okay, na? B cos C plus C cos B. Now this one I am just underlining here. B square cos square C, C square cos square B, to apply to availability of applying projection rule. Okay, na? So I am writing those two. That means B square cos square C minus C square cos square B. This one as a pair plus. So BC after CA. That means C square cos square A. This one. C square cos square A minus A square cos square B, this one. A square cos square C plus remaining terms. What are the remaining terms? A square cos square B minus B square cos square C. A square cos square B minus B square cos square C. For availability I have to check that availability is from that projection rule I have taken. So first one is in the form of A square minus B square, A square minus B square formula, A plus B into A minus B. So this one we can write B cos C plus C cos B. A plus B into A minus B. What is A minus B? B cos C minus C cos B. Okay. So remaining two also similarly we can write. Now observe this one, B cos C plus C cos B is value is small a according to the projection rule. So that means A into B cos C minus C cos B. Similarly, this one C cos A plus A cos C. C and A nothing but small b into C cos A minus A cos C. That means this term you should write completely. Plus this one A and B means small c will come. Small c into A cos B minus B cos A. Just multiply all of them. This will be AB cos C minus AC cos B. And it will be BC cos A minus AB cos C. This one CA cos B minus BC cos C. Just identify any common terms. AB cos C minus AB cos C or similar C plus AB cos C minus AB cos C cancel becomes 0. Now BC cos A plus BC cos A minus BC cos A also cancel. What are the remaining? CA cos B and minus CA cos B. These two also cancel. All cancel means becomes 0. So therefore this entire value is becomes 0. Okay, right answer 0. So for this we need to do this much of process. Please note that. We will go to the next problem. Yeah, problem number 2. The problem number 2 is the value of A cos B plus B cos A. Directly from the projection rule, A cos B plus B cos A value is C. Now question number 3. The question number 3 is 5, 12, 13 are the sides of a triangle. 5, 12, 13 are sides of triangle means it will give the Pythagoras theorem will give you that right angle triangle. 5 square plus 12 square. 5 square value 25, 12 square value 144. So 144 plus 25, 169. 169 is the square number of 13. So it will create a right angle triangle. For this right angle triangle, circumcenter will be exactly half of the hypotenuse. So here we have to find out the value of radius, right? Yeah, radius, circumradius, capital R. So according to the right triangle, circumradius is half of hypotenuse. Circumradius is half of hypotenuse of right angle triangle. Okay, na? So from this 1 by 2 into 13, 2 times 13, 6.5 times. Okay, so let us go to the question number 4. That is the value of C minus B cos A by C minus C cos A. Sorry, B minus C cos A. Right, first one. So again I am just applying the projection rule. The small c I can write as C of A cos B plus B cos A minus B cos A. Projection rule I applied. So in the place of C I have written this much by using the projection rule. In the place of small b I can write C cos A plus A cos C minus C cos A plus C cos A minus C cos A cancel plus B cos A minus B cos A cancel. What are the remaining? A cos B by A cos C. So A also cancel. The answer is cos B by cos C. Okay, na? In the place of small c I have written projection rule. Small c rule is A cos B plus B cos C. Okay, na? Let us go to the next problem. Problem number 5. Yeah, A value, B value and angle A also given. Then the C is the root of the one of the equation. So A is equals to 4, B is equals to 3, angle A is equals to 60 degrees. Angle A is equals to 60 degrees. So let us try to find out the value of C is a root of equation. Okay. So let us, I'm just going to apply the value of using the cosine rule. What is cosine rule? C square is equal to, C only we should find now, C square is equals to A square plus B square minus 2AB cos C. Okay, na? But here A's value is given. Let us try to take cos A value. That means A square is equals to B square plus C square minus 2BC cos A. Just substitute the values. A square value 4 square, B square value 3 square, C square we don't know as it is C square, minus 2 into B value 3, C as the C, cos A. That means cos 60 degrees. 4 square value 16, 3 square value 9, plus C square minus 2, 3, 6, C, cos 60 degrees. Cos 60 degrees value is 1 by 2. 2 table in 6, 3 times cancel. So 16 plus 9, bring this side minus 9, 16 minus 9 is 7. 7 is equals to C square minus 3C. So take plus 7 also that side, it will be C square minus 3C minus 7 is equal to 0. This is the required quadratic equation. Okay, no? And sixth question. So the sides of a right angle triangle are in AP, then they are in the ratio. Right angle triangle ratio always must be first. Sum of the squares of first two sides is the square of third side. According to that, we can see we can go through the options, that is 3:4:5. 3:4:5. 3 square plus 4 square is equal to 5 square. Okay, no? There in AP means the difference is 1. Now let us go to the seventh problem. Seventh problem is same like fourth problem only. In the place of small c, how I applied the projection rule, you can try seventh one by using the same method. So let us go to the problem number 8. Yeah, the problem number 8 is, in a triangle sigma a cube into cos b minus c. Sigma a cube into cos b minus c. Yeah, it is a somewhat huge problem, so we will discuss in the next period. Okay. So that's it for today, children. Thank you one and all. Have a nice day. Bye bye.